In this video, I am going to give the brief description about frame of reference. Frame of reference. Well, if a car is moving at a speed, suppose this is a car, and this car is moving at a speed, say 50 km per hour. Right. So what does it mean? It usually means that the car is moving with respect to the surface of Earth. So let me just draw the surface of Earth. Car is moving with respect to surface of Earth. Alright. However, you know it very well, the Earth is revolving and rotating. So rotating about its own axis and revolving around the Sun in an elliptical orbit. The speed is said to be 30 km per second. Just make a note. So if you are at Sun or close to that, your speed will not appear as 50. Rather, your speed of the car will be 50 plus we need to add this 30 km per second. So the place from which the motion is observed and measured, I think I should write the place from which motion is observed and measured is called reference frame or frame of reference. In order to measure motion, to locate the position of an object, we need a coordinate system, and this coordinate system is attached to some specified body, say Earth. Unless stated otherwise, frame of reference means a coordinate system attached to the Earth. So we can add clock to this frame of reference to measure time. Later on, you are going to study that Earth is not a perfect frame of reference. Let's talk about motion in a straight line. So we can describe the motion of an object in two ways. One is mathematical equation, mathematical equations, and the second is with the graph. With the graphs. In order to study the motion graphically, we must be able to measure the position of the object and time. So, since motion along the straight line, one-dimensional motion is the simplest, we will try to describe the concept. So, first is the, I would say, position measurement. Position measurement. That means how we are going to locate the position of an object. So we need a frame of reference. A convenient way is to fix the coordinate system to a surface, and we can draw two axes, say x and x dash, and this as y and y dash. The intersection is O, and this direction is positive, this direction is positive. So this one is negative and this one is negative. Let me just correct this. This is negative and this is also negative. Well, an object moving along x-axis or y-axis undergoes one-dimensional motion. So if we are having, say, if an object is moving in this direction or in this direction, or for that matter, object is moving in this direction or in this direction, this is a one-dimensional motion. Similarly, we'll talk about time measurement. So, time measurement, we can add a clock to our frame of reference. So, let's add one clock here. Alright, this is clock. And in order to describe the motion of an object, it is necessary to choose some instant of time as the origin. So, this instant is assigned a zero value. Say t is equal to 0, the particle starts moving. Say t is equal to 0. So, in fact, t is equal to 0 is the instant at which we start the study of motion. So, I think I'll give you some illustration, and it is like this. Suppose this is the origin here and a particle is moving like this at some time t1. It is at position p1 and the distance here is x1 or the displacement. So, here the particle is at p2, the time is t2 and the distance covered from origin or the displacement is x2. This is x1. Of course, I am going to explain what is distance and what is displacement later on. So, in one-dimensional motion, magnitude of displacement, is equal to distance. So, let's talk about now description of motion. Description of motion. Now, to describe the motion of an object, we need the concept of displacement, velocity, and acceleration. We need all these three concepts: displacement, velocity, and acceleration. And you know it very well that these are vector quantities. They have the magnitude as well as direction. So, first we will come to the displacement versus a distance. Displacement and distance. Well, let's talk about the distance first. Distance is nothing but the total length of the path, traveled by an object. During a given time. So, The distance is a scalar quantity and the value cannot be negative. It cannot be negative. Say for example, you are at point A and you are going at point B, and suppose you are going like this and you landed up here. So the total length of the path traveled by an object during a given time is called distance. Now, what is displacement? This is nothing but shortest distance from initial position and final position. So this is the initial position and this is final position. Well, the shortest distance is going to be like this. So just let me just come up here. So this is your displacement and this is the distance. This is distance, total length. Well, the displacement is measured in meters in SI unit, and even distance is also measured in meters. But the best part is displacement can be 0, can be positive, and can be negative also. Now let's go back to the same example here. Here in this case, the displacement is written as delta x, which is going to be x2 minus x1. So this is denoted by this letter, Greek letter delta, and it doesn't mean that the delta is multiplied with x, it means the difference.